If you only look at per-query metrics, you miss where users actually struggle. We will build simple session-based analytics in Python to reveal painful loops and reformulations. You notice odd signals. Average click rates look fine, but users type the same idea 3 times before they click, or they leave after the second query. By grouping interactions into sessions, you reveal those loops and the abandonment that hides behind query averages. The payoff is concrete. You will spot problem queries, prioritize fixes, and measure whether a change reduces painful reformulations. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger real-world problems. Session-based search analytics is a task and a small pipeline. The practical problem is that single query metrics miss context. Engineers want to know whether a string of queries came from one search episode. Product teams want to know if users reformulate until they find something or if they abandon. Success means converting noisy logs into session signals you can act on, not a perfect user model. At small scale, this works on toy logs. At production scale, you apply the same logic on bigger event streams. The intuitive idea is simple. Group consecutive actions by the same user into a session based on an inactivity gap. Inside each session, count how many times the user changed their query text. Also check if the session ended without any click, which we call abandonment. For a tiny example, imagine one user who searched 3 times in 10 minutes with no clicks. That looks like a reformulation loop followed by abandonment. Strengths are clarity and actionability. Weaknesses are sensitivity to the session gap you choose. We will build a 5-step pipeline. First, we partition logs into sessions. Then we count reformulations per session. Next, we measure abandonment rate. After that, we test what happens when we shorten the session gap. Finally, we combine those signals into a simple priority score that highlights painful sessions. That keeps each step small and testable. This snippet partitions toy logs into sessions using an inactivity gap. It reads the toy log rows for each user, sorts them by timestamp, and computes the time difference between consecutive actions. Wherever the gap exceeds the threshold, it starts a new session ID. The key lines are loading the toy events, grouping by user ID, sorting by timestamp, computing the delta time, and assigning a session counter that increments when delta exceeds the inactivity gap. The main knob is the inactivity gap value. A larger gap merges more events into one session, while a smaller gap splits them, which changes downstream counts of reformulations and abandonment. Now we will count how many times users reword queries inside each session. This snippet counts query reformulations within each user session. It iterates over each session and compares consecutive query texts after basic normalization, such as lowercasing and trimming white space. Every time the normalized text changes, it increments a reformulation counter for that session. The core idea is not exact string matching versus semantic similarity. This toy example uses exact normalized equality, so identical repeated queries do not count as reformulations. The result is one reformulation count per session, which you can aggregate across users or filter for sessions with at least one reformulation. If you switch to a looser similarity measure, you will count fewer or more reformulations, depending on how you tune that threshold. Next, we will mark sessions that ended without any click and compute abandonment. This snippet measures session abandonment as the fraction without any click. It inspects each session's events for a click flag or click event. If a session contains no click, it is labeled abandoned. The snippet then computes the fraction of abandoned sessions over the total sessions, or you can compute abandonment per user or per query bucket. The important detail is where you look for click signals. Early clicks inside a session count as success. Dwell or follow-up events can refine the label. This metric turns session behavior into a simple failure rate that product teams can act on. Now we will experiment with a shorter inactivity gap and see how the metrics shift. This snippet tests how a shorter session gap changes abandonment. It reruns the same partitioning logic with a reduced inactivity threshold and then recomputes reformulation counts and abandonment flags. The point is to compare two configurations and observe how splitting or merging sessions alters your signals. With a shorter gap, you typically see more sessions, fewer reformulations per session, and potentially different abandonment fractions. This is a sensitivity test, not a correctness proof. Use it to pick a gap that best matches your expected user behavior, knowing that different product contexts may need different gap values. Finally, we combine the signals into a single priority measure for investigation. This snippet combines reformulations and abandonment into a simple priority score. It normalizes the reformulation count and adds a bonus when a session is abandoned, or applies weights that reflect your judgment. The code ranks sessions by that score, so you can inspect the top hitters where users looped and left. The main choices are the normalization method and the weights for abandonment versus reformulation. Tune them to balance sessions with many small edits against sessions that end without any engagement. The output is a short ranked list of sessions you should look at first. In a real project, you map this to your event stream. Partitioning becomes a pre-processor step. Reformulation detection lives in a small function. And the score feeds a dashboard or a review queue for analysts. Recap: session-based analytics groups events into sessions, counts reformulations, and labels abandonment. Use it when single query metrics hide user pain and you want actionable session signals. Caveat: results depend on the inactivity gap and on how you define reformulation. Next step: tune the inactivity gap and re-weight the priority score while comparing the abandoned fraction to see which configuration surfaces the most actionable sessions. If short, practical IR helps, subscribe and watch the other search and IR videos.